Hi everybody, you have completed your first learning log, and in this video I wanted to tighten them up a little bit. So whatever you did the first time was good because it's difficult for me to give clear instructions about what I'm looking for. But that's the purpose of this video, is to clarify how you can improve the quality of your logs by talking through some examples. So here we go. Each item in your log should be one of three things. It could be a note for yourself about what you need to study more. It could be you showing me how your understanding has changed or grew. So you can say, before I thought this, now I know this. Or you could show me the breadth or depth of your specific understanding of a key idea. So each of these three bullet points are something that you probably shouldn't write. So the I understood everything idea, that's none of these three things. It's not a useful note for me. It's not a useful note for you. It doesn't show anything specific about your understanding. So probably don't write anything that sounds like that. I'm still confused about logs is a good thing to kind of be aware of and acknowledge, but it's not very specific, and it's also not clear that it's like information for yourself. So better would be to expand and say, like, I don't understand the meaning, or I don't know how to use them to solve equations, or I need to practice with the shape until I remember them better. But the idea, again, is sort of it's a note to yourself about what you need to do, and then you can use that when you come to office hours. The third one, I retouched on the concept of finding an inverse from the original function. That's good, but it focuses on what you did rather than what you learned. Like, what did you take away from that retouching? So you could have a compare contrast. Like, before, I knew that an inverse undoes a function, but today I got good at solving for x. Blah, 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 right? Like that. Or you could also highlight aspects of it that you're still unclear about. So again, sort of the overall theme here is like try and be as specific as possible. And then also you can compare and contrast about what you knew before and how that either changed or got built up. So this one was a very nice format. I liked this. I thought it was very clear. It could also be expanded a little bit. But what I liked about this was they've got takeaways, what I learned, things I need to touch up on, questions. So good organization. If I was touching it up, here are some of the things that I might do. So you'll see a lot of this is the same, like learned, logs, and exponentials or inverses. But adding a couple of connections or illustrations of kind of what that means for you shows me more of your specific understanding. So like, what does it mean for them to be inverses? You could have said, like, that means their graphs are reflections around y equals x, and like a specific example of of what that looks like would be log base 2 of 2 to the x equals x. Like maybe in your mind that's obvious and doesn't need saying, but like those kinds of connections are very often the things that some students who think that they understand the topic are missing. And like those connections are the things that you really need to have in your head in order to solve problems. Like it's not enough to know the fact that they're inverses. That has to have a whole bunch of specific associations for you that come to mind whenever you see something is an inverse, because it's those associations that are going to let you solve more difficult problems. So the single line item, logs have an x-intercept of 1, like give an example or say why, or say how that connects to exponential graphs. For things that you need to touch up on, like root laws, that's good, but I think it would be good to be a little bit more specific than just saying root laws. So if you could say, like, for example, like problem 3b, or for example, like this kind of thing, just give it a little bit more specificity. So this one is also pretty good. I think it could also be expanded. And I wanted to highlight precision in language here. So one thing I really liked about this is the because there. So, so this actual notation is a little bit weird and probably wrong. But they're saying like log base x of 1 is always going to be 0. And they're saying that the base is not allowed to be 0. And then they have the because anything to the power of 0 is 1. So like that's not just the fact, but also like the meaning behind the fact. The precision in language thing is more about this last one. So the inverse of exponents normally results in a log. I would say always results in a log. And like that's in everyday speech, that might not be a big difference. But when speaking mathematically, it's a huge difference. It's the difference between saying something is like a fundamental truth, it's an objective truth of the mathematical world, and saying that, this is just This is true of many examples. This is kind of a thing that I've observed. I don't know who said it, but there's a quote that mathematicians are the guardians of precision and clarity of thought. And so try and really bear that out as you write your learning logs as best you're able. You are still, young, developing mathematicians. So this one's also quite good. It could also be expanded upon by using brief examples or illustrations. So I really actually like that first bullet point. It may not seem like it has some specific mathematical content, but it's like a really important insight about the kind of thinking that's required. So that top bullet point I think is great with no changes. The second bullet point is also great because it does really highlight one of the main points, but it would be nice to add a whole bunch of examples of kind of how does that look or what does that mean for you. And then similarly for the third bullet point. So if I was going to rewrite this one, I would rewrite it something like this. So that first bullet point I didn't change except that I kind of broke it into two pieces. I said it's important to think about the problems logically rather than just mathematically. And then an illustration of that idea is x squared could be mathematically inverted, but it would not make sense because blank. And so that's actually a piece that was missing from the original was the because. For the main point that inverses undo each other, you could just add a couple of quick bullet points about like what does that look like? What does that mean? And then for the third point, functions that normally can't be inverted are able to be if you use a domain restriction. Again, just a quick example, like if it's x squared and you restrict the domain to x less than or equal to 0, then the inverse is negative root x, and that makes sense because blah. Or if you're not sure why it makes sense, it's totally fine to write it's invertible because I'm not sure how to explain it. Like that's also useful information, so for sure write that. But if you just write the facts themselves don't really show me very much beyond the fact that you know some facts, and knowing some facts by itself isn't really very useful. So just a couple more examples here. I kind of highlighted two bullet points that I think could be expanded upon. This first one is actually not precise enough in its statement. Like you can't find an inverse if there are two outputs. Well, most functions have an infinite number of outputs. So I think this literal sentence isn't probably what this person was thinking in their head. It's just that that's what they wrote down like is too vague to actually have like a relevant meaning to this problem. And then the last bullet point is like very precise in its wording. I think that's great, and I love the fact that they're kind of highlighting a restriction on B, but it's missing the because. It's missing like why should that be a rule? Why does that make sense at all? This was a great takeaway. Not every function is invertible. That's a huge realization if you hadn't thought about it before. But show me some examples. Like what was it in the problem set that made you have that realization? So in conclusion, here's a couple of rules of thumb. Try and add a short because, try and add short examples or illustrations, and try and highlight connections between ideas and problems. That's going to go a huge way towards making your learning logs more useful for you, but also kind of showing me what your mathematical understanding is. So what I would do is write your learning log, then go back, look at each sentence, and ask yourself, is this sentence really generic? And if it is, try and add one of the things above. If you find that you can't, then probably just delete the generic sentence because it's not helpful to clutter up your log with some generic sentences. Okay, good luck. Part of your homework is to revise your first learning log by kind of expanding it in these ways. And then to write a new learning log specifically about the most recent problem set. I realize that part of the difficulty in this is with the mathematical notation, and like piecewise defined functions are very hard to notate. So do your best. If you're able to put in screenshots from your actual written work, that would be wonderful, but certainly not required. I would say just do your best to be specific in showing me your mathematical understanding while working with the kind of notational issues. All right, good luck, everybody.